Welcome to our channel. Today we have picked up a problem from Pythagoras theorem, exercise 13b, question number 5, the latest edition from Selina Publications, grade 9 ICSE. This particular question has multiple right angle triangles and there are multiple subparts. So this becomes a bit challenging for the students to understand the way of picking up the right triangle so that they can proceed with the right sum, and this can be done in a short time. So here let's identify what you're supposed to do. Here the first thing that we need is pm square plus rn square. If you look at pm square, this is the hypotenuse of the right angle triangle. That triangle is pqm. Then we needed a rn square, which is rn is the hypotenuse of triangle rnq. So we have rightly identified the two triangles that we should be working in. So let's start. So if we look at the first one, that is in triangle PQM by Pythagoras theorem, what we pick up is PM square is PQ square plus QM square. Here we got the first part. Then we have to move on to Rn square. So here in this case we look at triangle. We are looking at the triangle in triangle RQN. Again by Pythagoras theorem. So this is statement has the reason, which is Pythagoras theorem. So we picked it up here. So we will get Rn square is equals to nq square plus rq square. So we needed an addition of these two. So we're putting this as statement number 1. This is statement number 2. Here we'll say adding 1 and 2. Adding statement number 1 and 2. What we get is, therefore pm square plus rn square is pq square plus qm square plus nq square, that is nq square plus rq square. Now if you look at the right hand side we need 5 mn square. Mn is the hypotenuse of this tiny triangle. So PQ should be spoken in terms of NQ. RQ should be spoken in terms of MQ. So because these are the midpoints, so we know these are the midpoints here. This is the midpoint. So we are able to replace PQ with 2QN. So here we write 2QN the whole square plus qn square, which is, we have picked this and we have written it here. Then we needed a plus qm square, which is, we have taken this from here, plus rq can be written as 2qm the whole square, which means now we will have 4qn square plus 1qn square plus 1qm square plus 4qm square, which when we add them it becomes 5qn square plus 5qm square. If we do the factorization, we get 5 out, qn square plus qm square. So from the triangle, qn square plus qm square gives us mn square. So this becomes 5 mn square. So we have got the proof. The proof for the first part was, this was required to be proved, equals to this. So we have got this part first. So if we just highlight this, we have the first part here with us. Now we move on to the second part. The second part is, here we want to prove this. So let's take the second part. Okay. In the second part, we needed 4 pm square. So we know pm is here. We needed a pm square. Since this is the hypotenuse of this right angle triangle, it is worth applying Pythagoras theorem in triangle PQM. So we are looking at in triangle PQM, in triangle PQM, again by Pythagoras theorem, we're going to write it as pm square. So pm square is equals to pq square plus qm square is equals to pq square plus qm square plus qm square. Here if you realize, we need pm square, we have pm square. We needed a pq square, we have pq square. We need qr square, but we have qm, and from the triangle qm is half of qr, so we'll replace qm with half of qr. So we will get, therefore pm square is pq square plus half qr the whole square. So this becomes pm square is pq square plus qr square over 4. So we want to get rid of this 4. So the best way of getting rid of this 4 in the denominator is multiplying each term with 4. Just multiplies with 4, and we have a multiplication with 4 here as well. So now we have a chance of getting rid of this 4 with this 4. So this will leave us with therefore we get is 4 pm square is 4 pq square plus qr square is the second proof that we have done. We are left with 2 more. So let's continue solving this further. So the next one that we want to do is this one. So we pick it up here. We are picking this one. So we go to the next part of the proof. The proof is here. Alright, so we needed a 4 Rn square. We'll identify Rn square is here. Rn square is here. Since this is the hypotenuse, so we know the triangle that we should be working in is triangle RNQ. So we'll apply Rn square is RQ square plus NQ square. Rn square. So in triangle RNQ, again by Pythagoras theorem, we are getting Rn square is equals to NQ square plus RQ square. RQ could be written as QR, so we'll write this as QR square. So QR the whole square. So we naturally don't want the NQ. So if you look at the triangle, NQ can be written as half of PQ. So we'll do the replacement of half of PQ because N was a midpoint. So we get, therefore Rn square is equals to NQ is half of PQ the whole square plus QR square. So this would become Rn square is PQ square over 4 plus QR square. So we're going to get rid of the denominator 4. We'll multiply each term with 4. So we multiplied with the 4 here, we multiply with 4 here, and we multiply here as well with 4. So we are getting rid of this 4 and this 4. We are now left with, therefore we get 4 Rn square is equals to PQ square plus 4 QR square. So we have technically obtained the third proof as well. Now we are left with the fourth proof. So we'll go ahead with the fourth proof. So picking up the fourth proof here. The fourth proof. The question is taken from here. We apply it here. So here we go ahead with the proof. So technically this question is now demanding 4pm square 4pm square plus 4rn square. 4rn square is already here with us, so we need to add these two statements. If we had labeled these two as, let's call this as Roman 3 and this statement as Roman 4, we will add 3 and 4. So the statement here is adding statement number 3 and 4. What we get is 4pm square plus 4rn square is 4pq square plus 1pq square plus 1qr square plus 4qr square. So when we add them up, it is here. So is equals to 4 plus 1 makes 5. It becomes 5pq square plus 5qr square. If you look at the addition of these two, pq square plus qr square gives me pr square. So I'll replace this with a pr square. So this becomes is equals to 5 times pq square plus qr square is equals to 5 times pr square. So thus we have succeeded in proving. What we finally get is 4pm square plus 4rn square is equals to 5pr square. So we are finally done with the proof, and we will meet again with another challenging video. Thank you so much for watching.